And for the third problem, let's draw the shapes given by these two sets. So the first set, S1, is going to be all points x, y, z in R3, such that z is equal to x squared plus y squared. And the second set, S2, is going to be all points x, y, z in S3, R3, such that z squared is x squared plus y squared. So these two look very similar. The only difference is that there's a square on the z in the second set. So what's the trick to knowing what these two look like? So here's a convenient observation. So notice that in both cases, z is purely a function of the radius. Now, what is the radius? The radius is just square root of x squared plus y squared. So it means if you imagine z being a function of both x and y, then this function doesn't care where actually your x and y are, as long as they are the same distance from the origin. So what this means is that both shapes, S1 and S2, are radially symmetric. So radially symmetric means if you just turn it around the z-axis, it will look the same. For example, a cylinder is radially symmetric because if you turn it around the z-axis, it looks the same, right? It doesn't change at all. So it suffices to just know one piece of both graphs. Then we can use radial symmetric, use the property that they're radially symmetric to figure out what they look like. And so if we set y equals 0, this means we're just projecting this shape onto the xz plane. Then we get, for the first one, z equals x squared plus y squared. We have z equals x squared. And this is just a parabola, right? So this is going to be x, and this is my z. And for the next one, z squared equals x squared plus y squared. I get that z squared is x squared. So it means that z is going to be plus or minus x. Let me draw it on the left here. Right. And because these two shapes, we just observed that they're radially symmetric, the resulting shape is just going to be these two curves rotated along the z-axis. So the first one is actually like a cup shaped in the shaped as a parabola. Second one is going to be two cones connected in this way.